Okay, so we're going to try out a free response question now. So this used to be more typical on the AP exam. You're less likely to see it exactly in this format. Sometimes it might have a couple more complex things. You'll see that in your IP. This is more of a straightforward one. So we have this differential equation, dy dx equals x over y. We'll be using that throughout the problem. So part A says sketch the slope field. So I can go point by point and draw in all the slopes, just x over y. But remember some shortcuts here. Dy dx, my derivative, will equal 0 when x is 0. And it will be undefined when y equals 0, since I can't divide by 0. Now, what you'll see on the AP test, if they ask you to do that, they will not ask you to draw these lines when your derivative is undefined, because even though that might be a vertical line, sometimes it's not. So we'll go ahead and just put our 0 slopes in along the line x equals 0. And then let's find our other slopes. So just go point by point. We're not going to draw any along the x-axis because y is undefined there. So actually, I should get rid of this one since it's undefined when y equals 0. All right, so if I go to this coordinate, I'm thinking of the x-coordinate 1 over 1. 1 divided by 1, that's going to be a slope of 1. Next, I have the coordinate 2 comma 1, and so 2 divided by 1 is going to be a slope of 2. It's going to be a little bit steeper. If I go to the coordinate 1 comma 2, that's going to be 1/2, which is less steep. And then if I go up again, 1 comma 3, that's going to be less steep. So I can see these are going to get less steep as we go. 2 is going to have a slope of 1, and then less steep 2 over 3. Again, that doesn't have to be perfect. What I can say though is I know I'm going to have a slope of 1 when x and y have the same coordinates. So that's along this line, y equals x. And they'll have a slope of -1 when they have opposite coordinates. So if I go to -1, +1, I know that's going to be a slope of -1. -2, +2, slope of -1. Same thing over here. That's going to help me fill this out. And then I can see if I went to -1, +2, that's going to be a slope of -1/2, so a little bit less steep. And then this would be -1/3, a little bit less steep. Over here, -2, +1, that's going to be a slope of -2, so more steep than the line up above it, and then a little bit, less steep. So again, you don't have to be perfect on these, just think about, is it going to be more steep or less steep than the one before? So same idea here. I know I'm going to have positive slopes in this quadrant because x and y would have the same sign, so they'll cancel out. So if I go -2, -1, that's going to be a slope of +2, so more steep than before. And then it gets less steep as you go. Again, this does not have to be perfect. They're just looking for some comparisons. So we can use symmetry over here to help us. So that's part A. We've sketched our slope field. Next, part B is to sketch a solution curve that passes through the point 0, -1. I'm going to go ahead and switch my color so you can see our graph. So first of all, you want to find the point 0, -1. So 0, -1. Make sure you have that point clearly marked. If that point is not there and it's not obvious that you're going through that point, you're not going to get credit on the AP test for your solution curve. After that, I'm just going to let my slopes guide me. And so over here, I know I'm going to be going down. Again, it doesn't have to be perfect. You do want to make sure to go to the edge of your graph. And then over here, just kind of go through the lines there. Again, doesn't have to be perfect, but make sure you go through your edge of your graph. For this last part, part C, it's asking me to find the particular solution to the differential equation with the initial condition f of 0 equals -1. So for particular solutions, that means it's actually asking me to solve for y. So I'm going to take my differential equation, dy dx equals x over y, and this is where I do the separation of variables. So if you have more questions about this, make sure you go look at 5.3. So I'm going to cross multiply. Y dy equals x dx. Remember, it's not always cross multiplication. It depends on your problem. In this case, that's what works, but you separate your x's and your y's to go with your dy's and your dx's. Integrate both sides. My antiderivative of y is y squared over 2. My antiderivative of x is x squared over 2 plus my constant. Let's go ahead and figure out what that constant is. I'm plugging in x equals 0, y equals -1. So 1/2 equals 0 squared over 2 plus c. So I can see that my c would just be this 1/2. So rewrite my equation. Y squared over 2 equals x squared over 2 plus 1/2. And now we need to solve for y. So I'm going to multiply both sides by 2. Y squared equals x squared plus 1. Let's bring it up here. Then to solve for y, I'm going to take the square root, but don't forget it's the plus or minus square root of x squared plus 1. And so we need to decide based on our initial condition. I want to be able to plug in 0 and get a -1. So if I plug in 0, 0 squared plus 1, that's just 1. Square root of 1 is 1. I know I'm going to need to choose the negative square root there. If I had chosen the positive square root instead, that graph would be up here, not at 0, -1. All right. That's the end of section 5.4. Go ahead and do your IP. Let me know if you have questions.